Hello, everyone, and welcome to the Million Mito Project, tracing the family tree of womankind. I'm Roberta Estes. You might know me from my blog, DNA Explain. I've been writing there for several years. I'm a genetic genealogist, a scientist, and a Million Mito Project research team member. The Million Mito Project is a collaborative science initiative. There are 4 team members: Dr. Miguel Villar, the lead scientist with the National Geographic Society Genographic Project; Dr. Paul Meyer, population geneticist with Family Tree DNA; Joran Runfeld, head of research and development, Family Tree DNA; and me. I write at DNA Explain. I'm a scientist, a genetic genealogist, and I was also a genographic affiliate researcher. The public participation phase of the Genographic Project has ended now, but the scientific research lives on thanks to all the people who gave permission for their DNA information to be used to facilitate research in the future. DNA was discovered in 1953 in the Cavendish lab in Cambridge, England, by Watson and Crick, of course. After they made the discovery in this beautiful old building, they walked down to the Eagle pub where they went for lunch every day. And they were so excited, they walked in and they announced to everybody that they had found the secret of life. They'd made a huge discovery. Of course, nobody knew what DNA was. So they just all kind of turned and looked at them and kind of like, that's nice, dear. And then they turned around and went back to drinking their brew. Now, while the pub patrons might not have been terribly excited about DNA in 1953, that all changed in 1981 when mitochondrial DNA was first sequenced. And of course, it's that that led to today. Why does all of this matter anyway? Well, genealogy, genetic genealogy, and the science of DNA are intertwined and inseparable. In fact, it's that science that allows us to use Y-DNA, mitochondrial DNA, and autosomal DNA to unravel the histories of our ancestors that we can't do any other way. The 3 types of DNA that we use for genealogy are Y-DNA, which is the direct paternal or surname line. Only males can test for this because only males have a Y chromosome. The mitochondrial DNA is our direct matrilineal line, so our mother's mother's mother on up the tree through all mothers. And males and females can both test for this because women give their mitochondrial DNA to daughters and sons alike. And autosomal DNA is for all lines. It's a cross-section, and males and females can take autosomal tests too. The tree of mankind and womankind is the scientific foundation for all of genetic genealogy. The tree branches are defined by haplogroups, which you can think of kind of as clan names. In fact, we can see the global history of humans in the Y-DNA and mitochondrial DNA maps. On the left-hand side, we show the Y-DNA map with Adam beginning in Africa and crossing through the Middle East and going on to populate all of the world, Europe, Asia, the Americas, and on down into Australia, every place in the world. On the right, we have mitochondrial Eve, everyone's mother, and the path is a little different, but it looks pretty much the same because, of course, we need males and females to populate the world. And so these 2 maps are what we're looking to redraw, specifically the map of mitochondrial Eve. We know a lot more today than we knew before. How does this work? Well, haplotree branches are defined by mutations. They're similar to genealogy trees. We should recognize that as genealogists. So in our example here, we have a progenitor, and the progenitor had 2 children, which we're showing as line 1 and line 2. Line 1 has a fuchsia mutation, and line 2 has a green mutation. And as we move on down those lines, some people have more mutations and some don't. So line 4 on the left-hand side doesn't have any new mutations, but line 3 has a white mutation. So every subsequent generation inherits the mutations that the parents had, and they might have some new ones. Now, of course, when we're expanding back tens of thousands of years, the mutations accumulate and they show branches, and we can track them back like breadcrumbs through the sands of time. The Y-DNA tree has grown exponentially. In 2010, the tree had 441 branches. And in July 2012, Family Tree DNA, along with the Genographic Project, had 850 branches and had tested 13,000 Y-DNA SNPs. And we thought that was a huge, huge accomplishment. By November of 2013, there were 6,200 branches using 50,000 testers' results. This tree was growing like crazy. And in February of 2020, there were 26,600 individual tree branches and over 500,000 identified and waiting on companion branches to be discovered to be placed on the tree. This has been done through citizen science, testing and focus. Citizen science is where citizens test and they, in essence, push the science forward so that we can build out the branches of the tree. This is what happened with the Y-DNA tree, and now we're looking to do the exact same thing with the mitochondrial DNA. With mitochondrial DNA, in 2012, we were using Build 14, which had 3,500 haplogroups sequenced from just over 8,000 sequences of people that have tested. By 2016, we had moved to Build 17, which is still the current build, which had 5,400 haplogroups from about 25,000 people. So a lot more people. But 2020 saw a huge increase. Today we have over 500,000 full mitochondrial sequences available between Family Tree DNA and the Genographic database. But we'd really like to have 1 million to work with. So what are the benefits of science and genealogy combined? Well, for genealogists, this gives us something to work with. Do you have a matrilineal line that you need to break through? Well, I certainly do, and I've broken through some of these using mitochondrial DNA. So the more people that test, the more genealogy testers out there, the more trees, and the more chances we have to break through those brick walls. We've achieved critical mass for autosomal. We have 30 million autosomal testers. Just think if a fraction of those would take mitochondrial DNA tests, how much progress we could make on those lines that we can't break through because there aren't any surnames. We have success stories even with limited testing, but we need more tests, more testers, and more trees. So citizen scientists need to come to the rescue. In other words, we need you. How can you participate in the Million Mito project? Well, you need to test at Family Tree DNA, and you need to take the full sequence test. If you previously tested at the lower HVR1 and HVR2 level, it's easy to upgrade. Just go to your personal page and click. The full sequence results will be used to expand the tree of Womankind. Many new haplogroups will be defined, and we'll be rewriting that tree together. It benefits you, and it benefits science. The test at Family Tree DNA is $159 if you haven't tested there, or you can upgrade if you've already tested at a lower level for $119. So, what's next? Well, we're excited. We plan to publish a paper, at least one, in 2021. There'll be lots of exciting discoveries, which means you'll have more meaningful matches. The haplogroups will be much more refined. Family Tree DNA will notify their customers, of course, and I'll be writing at DNA Explain. I promise you that. You can find articles there. The team members will make presentations to various groups, and in the meantime, you can join the Facebook Mitochondrial DNA group, where you'll find most of us hanging out. In fact, you'll find the collaborators there. We hope to see you in the Million Mito Project. We hope to see you in 21. So order a kit, stay in touch. Thanks a lot.